Okay, so we are looking at our last trig graph, cubic graph that we're going to draw for now. And so remember, the first thing we're going to do is we're going to find the y-intercept, and we're going to do that by letting x be 0. So that's very easy, 0, -4. Next up, we're going to look for our x-intercepts, and there will likely be more than one of them. All right, so we're going to let y be 0. Okay, so we're going to get minus x cubed plus 3x squared minus 4 equals 0. We're going to multiply everything through by minus 1. That's just a little bit nicer to deal with. Right, now we need to try and find a solution by inspection. Let's try 1. If we try 1, we get 1, subtract 3, that's -2, plus 4. 1 doesn't work. If we try -1, now remember, when we cube -1, we're actually going to get -1. When we square -1, we're going to get 1. So now we've got -1, subtract 3, that's -4, plus 4. Yeah, -1 works. If -1 works, x plus 1 must be a factor. Right, let's see if we can find the other factor. We must have an x squared. And we must have a plus 4. At the moment, we've got a plus x squared and we want minus 3x squared. So in fact, we need -4x in here. Right, just as a final cross-check, I'm going to check that my x's come out right. X's are going to come from x's with numbers, there's 4 of them, or numbers with x's, there's -4 of them. In fact, there are no x's and I didn't want any x's, so it's perfect. Okay, next up we're going to see, does this equation, this quadratic equation, have any solutions? All right, and in fact it does, because it can factorize to x minus 2 all squared, x plus 1. So we got x plus 1, we got x minus 2, and we got x minus 2. Okay, and so there we go. X equals -1 or 2. Right, now notice that 2 is actually kind of repeated. Okay, so that when that happens, the graph will actually turn on the axis. So just remember that. Okay, I'm just going to highlight that yellow because I want to come back and talk about it a bit later in this lesson. When that happens, we actually get a turning point on the axis. Let's just see. Remember how we find our stationary points? We're going to let the gradient be 0. We're going to let dy dx equal 0. And when we do that, remember how we differentiate -x cubed, -3x squared, plus 6x equals 0. Okay, and now we can divide both sides by -3. We get x squared minus 2x equals 0. And this, in fact, factorizes to x into x minus 2 equals 0. So as I promised you, one of the turning points is actually at 2. So x equals 0 or 2. Now these are nice, easy ones to work out, because 0 we've already worked out is at -4. So we know that this graph is going to turn at 0 and -4. It's also going to turn at 2, 0. And we know, finally, we know that it's got an x-intercept of -1. Right, so what actually happens with this graph is it comes downhill. Then it goes there, and it turns there. Then it goes uphill, then it turns there, and then it goes downhill again. So it actually only has 2 x-intercepts, one at -1, one at 2. Okay, right. Just something we want to quickly talk about now is that, let's just go back and look at all 5 of the cubic graphs that we've drawn. Okay, there was the first one. I want to draw your attention to something here. When this number at the front is positive, the graph goes uphill and then downhill and then uphill again. When it's positive, it goes uphill first. Have a look at this one. It's positive. The graph goes uphill first. Have a look at this one. It's negative. The graph goes downhill first. Okay. Have a look at this one. It's positive. The graph goes uphill first. Have a look at the last one we've just done. It's negative. The graph goes downhill first. Okay. So what we're going to do now, we're going to find the equations of cubic functions where we are given all three x-intercepts. Exactly the same as we did with parabolas. We're going to have x minus each of our roots. Okay, but the only thing that we must just be careful of, and I'm going to highlight it in yellow here, if we have a repeated root, okay, a root which occurs at a turning point, then we must square that factor. So I'm just going to go and show you again here. That factor was actually x minus 2 must appear twice, or x minus 2 all squared. Okay, let's have a look. Let's do some examples. We'll do one together, and then I'll do two together, and then I'll ask you to do the other two. All right. So this one over here, and I'm sorry I haven't left much space here, but we know that it's got roots of minus 2 and 1 and 3. That means it must factorize to x plus 2, x minus 1, and x minus 3. Okay, right, now we don't know what a is, but we do have a point that we can substitute. So now what we're going to do is we're going to substitute in this point 2, negative 8. 2, negative 8. 2 for the x's, negative 8 for the y's. So we actually get negative 8 equals a. 2 plus 2 is 4. 2 minus 1 is 1. And 2 minus 3 is negative 1. Right, so on the right hand side here, we've actually got negative 4a is negative 8. Negative 4a is negative 8. So in fact, a is positive 2. So our equation, all right, the equation of this graph is y equals, I'm just going to write it with a green pen, it's y equals 2 into x plus 2, x minus 1, x minus 3. Now that's not in standard form. To get it in standard form, we would multiply it out. Okay, and I'm just going to do that quite quickly. When we multiply x plus 2, or x minus 1 by x minus 3, we're going to get x squared. We're going to get minus x minus 3x. We're going to get minus 4x. And we're going to get a plus 3. Okay, when we multiply the x plus 2 in here, we're going to get x cubed. We're going to get 2x squared minus 4x squared. It's minus 2x squared. We're going to get negative 8x plus 3x. That's negative 5x. And we're going to get plus 6. Okay? So plus 6. And then lastly, when we multiply the 2, we're going to get our final answer in standard form, y equals 2x cubed minus 4x squared minus 10x plus 12. Okay, I'm really sorry about the lack of space here. We will fix it before we print next year's workbooks. But there's our final answer. Okay, now we're going to do one more together because this one has got the repeated root. Okay, so because it turns at 2, it's going to be of the form y equals a, x minus minus 4, which is x plus 4, and then it's going to have x minus 2 all squared. Okay, and we just need to remember that the reason that this is being squared is because it actually turns there. Okay, now exactly as we did last time, we're going to sub in a point. So we're now going to sub in 1, negative 5, sub 1, negative 5. Okay, so we get negative 5 equals, now a, 1 plus 4 is 5. Okay, 1 minus 2 is negative 1, but when we square negative 1, it becomes positive 1. So we actually get 5a equals negative 5. We actually get a equals negative 1. Did we expect a negative coefficient at the front here? Yes, because this graph's going downhill first. Remember that little trick. Okay, right. So now the only thing we've still got to do is we've got to multiply it all out to get it into standard form. So y equals negative 1. We've got an x plus 4. Then we've got x minus 2 all squared. I'm just going to square that out. It's x squared minus 4x plus 4. Okay, it's going to be negative 1 into x cubed. We've got a 4x squared and minus 4x squared, so no x squareds. Okay, 4x squared and a minus 4x squared, no x squareds. We've got minus 16x plus 4x, that's minus 12x. All right, and then we've got plus 16. And then the last thing we're going to do is just distribute that negative in. So we're going to get negative x cubed plus 12x minus 16. Okay, I just want to pause this briefly just to check myself. Yeah, I'm happy. Okay. Right, we're going to ask you to pause the video and we're going to ask you to try the next two. Okay, now the next two, the first one I think is fairly straightforward. All right, the second one, what we're given here is we're given that point there and that point there. All right, and so that should help us. Let's see if we're going to ask you to try it. Pause the video, try both of these, and then we'll talk about both of them. Okay, so this first one is fairly straightforward because it actually factorizes into the form y equals a x plus 2 for the root of minus 2, x minus 0 or just x for that root, and x minus 3. But now we must sub in a point that lies on the graph. So we're going to substitute in negative 1, 4. All right, now when you put negative 1 in, we're going to get 4 here. So negative 1 plus 2 is actually just 1. Negative 1 here, and negative 1 minus 3 is going to be negative 4. So what we actually get here is we get 4a, positive 4a equals 4. So in fact, a equals 1. Right, so if we multiply this out now, we're going to get, if we multiply these two brackets, we get x squared minus x minus 6, but then we still need to multiply an x as well. So it's going to be x cubed minus x squared minus 6x. Okay. If you do it longhand, you'll hopefully see that I've got that correct. Okay. Right, now this next one's a little bit interesting. Can we tell the value of any of these variables just by looking at this? Well, we know the y-intercept is 4. So we know straight away that d is equal to 4. Okay? We also know that the derivative, so now we are looking for b and c. So we're looking for two things. All right? But we know that the point 1, 3 lies on this graph. So if we put 1 in for x, we're going to get 1 plus b plus c plus d, but we know what d is. We know that d is 4. Okay, so our y value is going to be 3. We're putting 1 in for x. 1 plus b times 1 squared, so this is b, plus c plus 4, that's going to equal 3. So we know that b plus c is in fact 5. Subtract 5 from both sides. B plus c is negative 2. we've got an equation. We need another equation. And the other equation is going to come about because we know that the derivative, the gradient at 1 is 0 because this is a turning point. Okay, at this point, y dashed is 0. So let's work out what y dashed is. Y dashed is actually 3x squared plus 2bx plus c. And when we put 1 in here, we must get 0. So we get 3 plus 2b plus c equals 0. And that's our second equation. Now we need to solve these two equations simultaneously. Okay, and quite a neat way of doing that is actually to take equation number 2 and subtract equation number 1. Now the reason that's going to work is because I've got two b's here. Sorry, I've got a c here and I've got a c here. So those will eliminate when I subtract the equations. So what we're going to do, we're going to take the bottom one minus the top one. On the left hand side we've got 3. We've got 2b minus b, which is just b. We've got c minus c, so those are going to go away. And we've got 0 subtract negative 2, which is positive 2. Now we've only got one variable. Halala. So let's subtract 3 from both sides. We get b equals minus 1. Now we know that b plus c is minus 2. Alright, so c is actually minus 2 minus b. C is actually going to become negative 1. Okay, C will be negative 1. You can check that if you want to do it a bit more slowly. So our final answer is going to be y equals, remember it was x cubed minus x squared minus x plus 4. Okay, that's difficult. I'd be lying if I said it was easy. It's not easy, but like all these things, it gets easier with practice. Okay, and the worst thing you can do is not to do anything. So you need to try something. Even if you just work out the derivative, you'll get some marks. Okay, we're going to see you next time. Next time we're going to talk about the second derivative, which is a really interesting thing. So we're going to talk about the gradient of the gradient. We look forward to seeing you then. Bye now.